So yesterday we were discussing about the input-output organization. Okay. So generally this input-output is a subsystem of your computer organization, and it provides a efficient mode of communication between input-output devices and your central processing unit. Okay. So it is going to handle all input-output operations which are related to computer system. So external devices are connected to this central system with help of what is called as interface. Okay, and all input output devices are connected to central processor with the help of interface using data bus, address bus, and control bus. And the way in which they are connected, which is shown in this block diagram. Okay. Now, next point that we must know is, and important from point of view of examination, is why there is need of input output interface. Okay, so why input output interface must be present between input output device and central processing system. The first reason is that the various type of peripherals, if you consider a hard disk drive, or you may consider keyboard, etc. These input output devices or peripherals, uh, the way in which they operate is different from the way in which the CPU and memory operate. Okay. So peripherals may be electromechanical devices, electromagnetic devices, and their signal values may be different as from that of your central processing unit. Central processing unit is a digital circuit. It is a digital electronic circuit, and it is dealing with only values zeros and ones. But the way in which the keyboards are operating, monitor is operating, or your memory is operating, so it is different. And so in order to bridge this gap, we need some intermediate circuitry. So this is the one reason why uh, we need interface. Second thing is about data transfer rate. Data transfer rate of peripherals is different from that of the data transfer rate of the central processing unit. Generally, central processing unit is faster as compared to peripheral units. Peripheral units, they are slower, and therefore, to cope with this speed difference, okay, there must be a mechanism to provide synchronization between these two different speed devices. Okay, so this is the second reason why there is need of interface between input output devices and the central processing unit. The second reason is the data transfer rates are different. The third reason is the data is stored in a format in CPU is different from that of the format which is stored in the peripheral. Okay, so the data formats related to CPU and data formats related to input output devices, they are different. Okay, so in order to make them compatible, there is need of intermediate circuitry. So this is the third reason why we are using interfaces. Okay. So another thing is the operating modes of peripherals. They are different as compared to operating modes of your central processing unit. So in order to again bridge this gap, the interface is present between input output devices and central processing unit. Okay, so as you can see, there are these four differences. One, the way in which the components are operating, the data transfer rate, the data code formats, and operating modes. So in order to resolve these four differences, the input output interface is present between input output devices and central processing unit. The function of the interface is to resolve these differences. Okay, so it is going to provide smooth transformation between peripheral device and central processing unit. So this is the reason why we are using the interface between input output devices and central processing unit. Are you clear about this? Yes, tell me, are you clear about this? काही शंका असेल तर विचारा. काही शंका आहे का कोणाला? नाहीये. पुढे जायचं आपण. Okay. So these are the functions of input-output interface. As far as your examination is concerned, you must know these functions of input-output interface. The first function is it is used to synchronize the operating speed of CPU with respect to your input-output device. So it is going to provide synchronization between different speed of CPU and peripheral. The second function of your input output interface is that um, it selects input output device which is appropriate for the interpretation of input output device. Okay, so this is second functioning. The third functioning is it is capable of providing control signals and timing signals in order to control the overall functioning of the input out or in order to control the communication between input output devices and central processing unit. So to provide the communication between these two components, the interface is providing control signals and timing signals. So this is another important function of the interface unit. So as I have told you, there is a speed difference between these two components. So there is need of data buffer which must be present in between to cope up with this speed. So this data buffering is also provided with help of this interface. Okay. During data transmission or reception, the errors may occur. Okay, so error detection and correction function, it must be provided by your input output interface. So error detection and error correction techniques or technologies are implemented in the interface so as to provide error-free communication between input output devices and central processing unit. Now, many times what happens, some peripheral devices, they are serial in nature and CPU is your parallel in nature. It operates parallelly. CPU operates parallelly and peripheral device, most of the peripheral devices, they operate serially. And therefore, when CPU is sending data to peripheral device, it becomes necessary to convert the parallel data into serial one. Okay, so this can be done with the help of shift registers. So we have studied parallel in serial out type of shift register, and such a shift register is present within your interface. So function of the interface is to convert parallel data into serial and vice versa. Vice versa means when data is sent from peripheral device to the processor, the data sent by this peripheral device is in serial nature and CPU will require it in parallel nature. So there is need again here to convert from serial to parallel. Okay. So again, this is done with the help of shift register, which is serial in parallel out. So using this type of register, interface is going to convert the serial data which is available from peripheral device or input output device to a parallel data. Okay, so thus conversion of serial data into parallel or parallel data into serial, this functioning is carried out by the interface. Okay, So sometimes what happens, some peripheral devices, they are analog in nature. They are not digital, but CPU is digital in nature, and therefore there is need to convert analog data into digital. Okay, so the signals from peripheral device, if they are analog in nature, they must be converted into digital to communicate with central processing unit. And when central processing unit wants to communicate with such a peripheral device, it is going to communicate with digital signals, and these digital signals must be converted into analog signals. So this conversion of digital to analog and analog to digital, this is also performed by your interface unit, which is present between input output device and central processing unit. So um, it is going to synchronize the operation speed. It is going to uh, send the data to appropriate input output device. It is capable of providing control signals, timing signals. It provides data buffering. It provides error control. It provides parallel to serial, serial to parallel data conversion. It provides analog to digital, digital to analog data conversion. So these are the functions which are carried out by the input output interface. Okay, so are you clear about this, students? Are you clear about this? Yes, tell me. Okay, then we will move forward. And here you can observe the block diagram of interface unit. So this is also very important. This dotted thing which is shown over here, this particular block. This is the block diagram of the interface unit. So you can draw a general block diagram of interface unit. So mostly all interface units, they have certain general functions. So considering this, we can draw the block diagram, generalized block diagram of interface unit. Now, if you observe, this interface unit is present between central processing unit and input output device. So that is what you can see here. And in the interface unit, you can observe different types of components. This particular component is called as data bus buffer. This component is very important component, which is control logic block. So this is a control logic block. So you can see it is capable of providing various control signals. So chip select signal, uh, S0, S1 is a select signal, RD signal is read signal, WR signal is a write signal. It is going to indicate which kind of this operation is, whether it is read operation or whether it is write operation. And all these operations are interpreted with respect to CPU. Whether CPU is going to write data into peripheral, then that operation is called as write operation. And whether CPU is going to read the data from peripheral. So this kind of operation is called as read operation. That is when peripheral is transmitting data to CPU, it is called as read operation. And when CPU is transmitting data to peripheral unit, it is called as write operation. Okay, so these control signals are present in the control logic block. So all these blocks are connected internally with help of internal bus. And here you can observe this is unidirectional bus, which is address bus. This is bidirectional bus, which is data bus, and these single lines here, which are present here. These are called control bus. Okay, so already you have studied these type of buses in this chapter only. Okay, so now here some more blocks you can observe. one block is called as port A, another block is called as port B. So these two are related with the data transmission and reception. Okay. So here, as it is dealing with the data, the bidirectional bus is there. So this port A and port B is internally connected with help of bidirectional bus, and you can see it is connected to data bus buffer, and it is connected to input output device again with the help of data bus only. Apart from these two port A and port B registers, this is also called as resistor, port A resistor, port B resistor, and this is called as control resistor, and this fourth thing is called as status resistor. So control resistor is going to control the input output device in a predefined manner, and this is done by writing command into the control register. CPU is going to write command into the control register, and the operations will take place according to this command. Okay, so the commands which are to be executed, input output commands, must be written into the control register. And status register, what it shows the current status of the input output device to the central processing unit. So when central processing unit want to communicate with input output device, first it looks the status of that input output device, whether it is busy or whether it is available. So this status is indicated with help of the status register. Okay, so now let us discuss this one by one. So as you can see here, what you can see, data bus buffer, this component. It uses bidirectional data bus to communicate with CPU. Okay, so all control word data and status information between interface unit and CPU, they are transferred through the data bus. So everything is transferred through the data bus. For example, control word data, that means command. Okay, it is transferred through data bus. Even status information which is provided by the input output device, it is transferred through the data bus. Okay, so this is what is the functioning of the data bus buffer. So it is going to store the command to be written into the control register or status which is available from the input output device. Okay, so that is written within this data bus buffer, and through this data bus buffer, it is sent to the central processing unit. Okay, now port A and port B registers, they are used to transfer the data between input output device and interface unit. Okay, so whenever data is to be transmitted from CPU to the input output device, or input output device to the CPU, then actual data which is transmitted in between is stored either in port A or in port B. Okay, so it is stored in port A or port B. So the data that is intended to be transferred between CPU and input output device is stored in port A or port B. Okay, so interface unit connect directly with an input device and output disk, or with the device that requires both input output through port A and port B. Okay, so it is bidirectional. Okay, bidirectional means either you can perform input operation or you can perform output operation, and sometimes both operations can be performed on a particular device. Okay, so if you consider keyboard, it is going to perform input operation. If you consider monitor, it is going to perform output operation. But if you consider memory, then it is going to perform both input as well as output operations. So such kind of devices are connected to the central processing unit, and therefore port A and port B They are used to store the data, and these two ports are connected with input output device and with central processing unit with help of bidirectional data bus. Okay, so this is important that you must remember about this. Now let us discuss about control and status register. Okay, so CPU gives control information to your input output unit through control register. Okay, so whatever command CPU wants to give to the input output unit, it will write this command into the control register. Okay, and it is also called as a control information. Okay, so various kinds of operations, those are carried out between central processing unit and input output device unit. They are carried out with the help of these commands, and these commands are written by central processing unit to the control register. Okay, so now what is use of status register? Status register bits, number of bits are present in the status registers, and these bits can be interpreted by your central processing unit, and these bits give the idea about the status of the peripheral unit or input output device to the central processing unit. It can even indicate whether error has occurred during the flow of data. Okay, so when data is transmitted from one device to another device, whether error has occurred during this data transmission, that error is also indicated by setting a particular bit into the status register. Okay, so this is all about the functioning of the various components which are present into the interface unit. Apart from this, we can see there is very important block which is used to generate the control signals for overall device operation. Okay, so it basically provides read-write control logic. Okay, so here you can see there is a signal CS, which is nothing but chip select signal. So when this chip select signal is enabled, at that time, when the chip select signal is enabled, when chip select signal is enabled, at that time, a particular interface will be selected by the central processing unit. So this signal is going to indicate whether that interface unit is selected by central processing unit or not. Okay. So this control logic is also capable of accepting the read control signal and write control signal, which is again coming from the CPU. So the signals which are present on this read and write line, they are going to indicate whether this is a read operation or this is a write operation. Okay, so here you can observe the input output device to CPU is a read operation, CPU to input output device is a write operation. Okay, so these two signals, read and write signals, they are going to define the direction of the data transfer over the data bus, whether it is from IO device to CPU or from CPU to IO device. Okay, now one more thing you can observe here is there are two select lines S0 and S1, and these two select lines are used to select any one of the four registers which are present in the interface unit. Which are the four registers which are present in the interface unit? Port A register, port B register, then control register and status registers. These are the four registers which are present in your interface unit. And these registers internally can be selected by central processing unit by writing the bit values to S0 and S1 lines. These lines are called as select lines. Now, if you observe this truth table, then you can see how these lines can be selected. So when chip select is made 0, that particular interface is selected because this chip select is a active low signal. So as it is active low signal, when it is 0, that particular interface unit is selected. And here you can observe in this particular operation, read line is 0. So again, read line is 0 means it is active low, and therefore read operation is carried out with help of this. When read line is 0, write must be 1, because read and write operations cannot be performed simultaneously. So when read operation is in progress, write operation must not occur, and therefore write signal must be at logic 1, read signal must be at logic 0. Now going to the select signals S0 and S1, they are used to select the different registers which are present into the interface unit. Now if you observe, when data 00 is present, port A will be selected. When 01 is present, port B is selected. When 10 is present, control register is present, will be selected, and when 11 is present, status register will be selected. Okay. Now here you can read data from port A, you can read data from port B, you can actually write data into the control registers, and you can read data from the status register. Okay. So that is what is here. You are going to write it through program written into the CPU. Okay. So CPU alters all these things. Now, in order to perform write operation, the same things are there, but only the difference is that your read signal must be 1 and your write signal must be 0. Okay. So in this case also, you are able to write to the port A, you are able to write to the port B, you are able to write to the control register, and obviously you cannot write to the status register, it can only be read. So out of this, you have to remember the thing that CPU can write to the control register, and it can read from the status register. Control register cannot be read, and status register cannot be written. Uh, Port A register and port B register, both of them, they can be written or read. So this is what you can remember about this. Now, this completes your this third chapter, that is basic input output organization. Do you have any doubt in this? Yes, Atharva, Sai.
No, ma'am.
ओके. मी काल काही गोष्टी Moodle टाकलेल्या आहेत, बघितल्या का तुम्ही? Moodleला जॉईन व्हा. असाइनमेंट दोनच लोकांच्या मला सबमिट झालेल्या काल दिसल्या, एक साक्षीची होती आणि एक मला वाटतंय तेजस दाभाडेची होती. बाकी सर्वांनी केल्या का सबमिट असाइनमेंट?
नाही मॅम, करायची आहे.
हो करा, आज बंद होईल ना ती लिंक 2 तारखेला.
हो मॅम.
हा, आज सगळ्यांनी करणं मस्ट आहे. साई, सगळ्या मुलांना सांगून दे, कारण 5 मार्काचं इव्हॅल्युएशन आहे ते. कोणी सबमिट नाही केलं की त्यांचे 5 मार्क जातील तिथे. आणि दुसरी गोष्ट, आता तुमची इंटरनल एक्झाम आहे, त्या इंटरनल एक्झामच्या बाबतीत असं पहिले 2 चॅप्टर मी ठेवते फक्त इंटरनल साठी, दोन्ही पेपरचे पहिले 2 चॅप्टर्स. ओके. म्हणजे हा पेपर जर इवन पेपर जर आपण कन्सिडर केला तर त्याचे पहिले 2 चॅप्टर्स काय आहेत, एक फ्लिप फ्लॉप आणि दुसरा काउंटर्स आणि शिफ्ट रेजिस्टर. ओके. याच्यावरती ती एक्झाम असणार आहे. आणि ह्याचा जर कन्सिडर केलं आपण तुम्ही इन्स्ट्रुमेंटेशनचं, तर बेसिक्स ऑफ ते सगळं इन्स्ट्रुमेंटेशन आणि सेन्सर्स अँड ऍक्च्युएटर्स, हे 2 चॅप्टर्स आहेत. म्हणजे 2-2 चॅप्टर्सची तुमची परफेक्ट स्टडी होईल इंटरनल एक्झामसाठी. मी जे काही प्रेझेंटेशन दिलंय ना, त्याच्यावर बेस्डच ती एक्झाम असणार आहे. ते सगळं वाचून घ्या प्रेझेंटेशन, आणि त्यातूनच तुम्हाला मी मल्टिपल चॉईस टाईप क्वेश्चन्स विचारणार आहे. ही इंटरनल एक्झाम आपली 10 मार्काची असते आणि ती इम्पॉर्टंट आहे. ओके. आणि प्रॅक्टिकलच्या बाबतीत तुम्हाला मी सुरुवातीला सांगितलं होतं की तुम्ही सर्वे कंडक्ट करायचा आहे इलेक्ट्रॉनिक्स प्रोडक्टचा. एखादा इलेक्ट्रॉनिक्स प्रोडक्ट घ्यायचा आणि त्याचा सर्वे कंडक्ट करायचा आणि त्याचा रिपोर्ट तयार करायचा आणि तो सबमिट करायचा. ओके. त्याला तुम्हाला 15 मार्क असतील. ते करायला चालू करायला हरकत नाही. कोणताही तुम्ही एखादं प्रॉडक्ट घ्या आणि ते वेगवेगळ्या कंपनीचे प्रॉडक्ट्स बघा आणि त्याचा सर्वे करून लिहा किंवा एखादी कंपनी घ्या, त्याचे वेगवेगळे प्रॉडक्ट्स बघा आणि त्याचा सर्वे करा. दोन्हीपैकी काही एक केलं तरी चालेल आणि इतर मुलांना पण सांगा हे. कारण मी त्याची पण लिंक टाकून देईल तुम्हाला तिथे. ते सबमिट करावं लागेल. त्याला चांगले 15 मार्क आहेत आणि इव्हन प्रॅक्टिकलच्या लिंक्स मी टाकणार आहे. तुम्हाला मी प्रॅक्टिकल लिहायला सांगितले होते. ते प्रॅक्टिकल लिहून त्या प्रॅक्टिकलच्या लिंक्सवर तुम्हाला टाकायचे आहेत. मी आजच या सगळ्या लिंक तयार करून टाकते आहे. तुमची असाइनमेंट आज अपेक्षित आहे मला आणि हे प्रॅक्टिकल वगैरे सगळं लिहायचं आहे. ते पण 1 बाय 1 लिहून टाका आणि सबमिट करा. ओके. कारण प्रत्येक गोष्टीला मार्क आहेत हे लक्षात ठेवा. काही शंका आहे तुम्हाला या बाबतीत? आणि असाइनमेंटचं पण मी बघितलं, त्या दोघांनी जी सबमिट केली असाइनमेंट ती खूप अशी शॉर्ट मध्ये सबमिट केली आहे. त्याचं काही डिस्क्रिप्शनच लिहिलेलं नाहीये. म्हणजे आता मेमरीच्या टाईप्स आहेत तर नुसती नावं लिहून टाकली आहे, तशी नसते ना असाइनमेंट. प्रत्येक टाईपचं थोडक्यात एक्सप्लेनेशन आलं पाहिजे. मग तुम्ही जर शॉर्ट मध्ये लिहित असाल तर तिथे मार्क पण तुमचे कमी होतील ना. तर त्याचं डिस्क्रिप्शन लिहिणं अपेक्षित आहे. तर तुम्ही लिहा ते डिस्क्रिप्शन सुद्धा. त्यांच्यासारखं सेम लिहून टाकू नका. सेन्सर्स आहेत, त्या मोबाईल मधले जे सेन्सर आहेत त्या प्रत्येक सेन्सरचं फंक्शन जरा असं डिटेलमध्ये लिहिणं अपेक्षित आहे. आणि मेमरीचे जे व्हेरियस टाईप्स आहेत ते टाईप म्हणजे काय, सेमी कंडक्टर मेमरी म्हणजे काय, रॅन्डम ऍक्सेस मेमरी म्हणजे काय, रीड ओनली मेमरी म्हणजे काय, हे थोडंसं डिटेलमध्ये लिहिलं पाहिजे. नुसते टाईप्स लिहिले आणि तुम्ही सबमिट करून टाकलं त्याला अर्धेच मार्क मिळणार, अर्ध्यापेक्षा पण कमीच. हे लक्षात घ्या. ओके. आणि त्या पद्धतीने सबमिट करा. आता आपण 70% जो सिलेबस म्हणतोय तर तो 70% सिलेबस कंप्लीट होण्यासाठी तुमचा जो पहिला पेपर आहे त्यातलं थोडंसं ऑपरेशनल ॲम्प्लिफायर होणं आवश्यक आहे आणि ते मी घेणार आहे. तर आज आपण त्याची सुरुवात करूनच टाकू. ओके. मी तुम्हाला पहिल्यांदा व्हाईट बोर्ड शेअर करते इथे. म्हणजे पुढचा जो चॅप्टर आहे तुमचा तो ऑपरेशनल ॲम्प्लिफायरचा. कशाचा आहे? ऑपरेशनल ॲम्प्लिफायर. आता ॲम्प्लिफायर म्हणजे काय हे माहिती आहे का तुम्हाला? सांगा मला. ॲम्प्लिफायरचा अर्थ काय माहिती आहे? येस अथर्व?
ऍम्प्लिफायर म्हणजे एखादी वस्तू मोठी करून दाखवणं.
हो बरोबर आहे. मोठी करून दाखवणे म्हणजे इथे आता इलेक्ट्रॉनिक्स मध्ये एखादी गोष्ट म्हणजे इलेक्ट्रॉनिक सिग्नल असतो, तो सिग्नल मोठा करणे हे काम ॲम्प्लिफायरचं असतं. तर त्याच्याकरता अगोदर ॲम्प्लिफिकेशन म्हणजे काय हे तुम्हाला माहित असलं पाहिजे. ॲम्प्लिफिकेशन म्हणजे एखादा वीक सिग्नल असतो, त्या वीक सिग्नलची स्ट्रेंथ वाढवणे विदाउट चेंजिंग इट्स फ्रिक्वेन्सी is called as amplification. Okay. Amplification is a process in which the strength of the weak signal is increased without changing its frequency. This is very, very important. Its frequency should not change when the signal is amplified. This is very important. So this process is called as amplification. And an electronic circuit which performs this process of amplification is called as an amplifier. So basically transistor is used as an amplifier. Okay. But this operational amplifier is an amplifier in the form of integrated circuit. Okay. Do you have idea what an integrated circuit is? Yes? Tell me. When whole circuit is fabricated on a single chip instead of fabricating it on a board, if it is fabricated on a chip, then it is called as integrated circuit. So operational amplifier is a type of integrated circuit. It is present in the form of integrated circuit. Okay, and it consists of number of stages of amplifiers. Okay, and first you should know the thing is why it is called as operational amplifier. So initially, this kind of amplifier was used to perform the mathematical operation. So amplifier was used to perform mathematical operations. So it is used in analog computation. Initially, the computers were not digital computers, but they were analog computers. And when analog computers were there, the operational amplifiers were used to perform the mathematical operations. And therefore, this type of amplifiers they were called as operational amplifiers. Okay, so now you came to know what an amplifier is and what operational amplifier is. Now let us draw the symbolic representation of this operational amplifier. Okay, so generally it is drawn in the form of triangle. Okay, so it has two inputs and one output. It requires bipolar power supply. Okay, so this is what is the speciality of this operational amplifier. So one input is designated by minus and another input is designated by plus. Okay, so here you can apply positive voltage and here you can apply negative voltage. So such a bipolar power supply need to be applied to the operational amplifier. So the terminal which is designated as designated by minus sign is called as